Good morning. Thanks for getting up so early and joining us for the optimizing session. We know there's a lot of sessions to choose from, and we're glad to have you. My name is Lloyd Heberlie. I'm a product engineer on the JavaScript API team, and I work a lot on the public-facing documentation website and mobile testing, and then I do the optimizing stuff with Rene.
Rene Rubalcava. I work on the JavaScript team and the apps group. Sorry about that. Yeah, doing lots of stuff.
So today we're going to cover talking about the web optimizer and what that is. Rene's going to talk about some of the other build options that you have using Bower and some other interesting projects or research that other folks within Esri are doing to create builds or to basically combine the modules into a bundled release format with some other technologies. And then along the way, we'll mention and talk about some other considerations, and then we'll take questions at the end. So in the first section here, we'll talk about the web optimizer. And instead of having a bunch of slides for that, I'm just going to dive into the doc and some of the other things that that we have. So if you go to the developer site for 320, under the references section, you'll see the using the web optimizer guide topic. And here at the very top, we make a note here. It says, you'll need to have an org account or a developer's account to log in and use the web optimizer. It actually writes your profile into like S3 buckets, so we authenticate you, we know that you have an account to write your profile and your builds into that storage. So you can't use a public account. You'll get an error if you try to create a build with that. I won't go into great detail about all this, but just kind of wanted to point out some stuff. Here's the part that says, if you have a public account, it's not going to work. That's kind of what the page used to look like. And then, when you sign in, you'll create a new build. There's different options for creating the build. You can upload a zipped app. And so if you structure your application appropriately and put in the right syntax for like the Dojo config, it will attempt to crawl through the code and find all the modules that you have in your application. I just want to just level with you here. If your app isn't structured correctly, this is not going to work. It's not a magic hammer where it's just going to traverse and, read through all the text files and do like a regular expression on all of them. It's just basically the build system hooking into your app and then determining which files are in there. So not saying don't use that, but I'm just saying, you've been warned. So we talk a little bit in here about how to, arrange your custom packages and the fact that they need a package.json in them. Excuse me. And the web optimizer actually looks for this as well. So that's one of the issues or gotchas with using that upload a zipped app. You can also enter a URL, and what this will do, this has to be a publicly facing URL, because the web optimizer will take that URL and fetch the content from it and pull it down and then try and inspect that code that you have in there to determine what modules you have in your application. The next option here is uploading a module list, and this is actually pretty awesome if you have the list. We'll talk about, I've got some stuff to show you how you can create the list, but this is like one of the most fail-safe ways of getting all the modules in your build single layer file if you can do it. But if you had to do it by hand, that's not a very fun operation to type all the modules in there line by line by line. But I'll show you a little nugget here in a little bit. And then finally, the last one is a manual selection. And we have, before we had the Web Optimizer option, the only two options for the build were the standard build, which is just like our best estimate or guess at what the common modules are that people use across most applications, or there was a compact version that had less of, say, like the Dojo widget stuff and just really more watered down. So that's a little history about why those two options are in there. But basically the manual selection, you can start off from our standard build or the custom build, and either one of those options will start you with a set of modules, and then you can go through and search for different modules and then start checking the checkboxes in the UI. So there's various options to populate this module list to say, these are all the modules that I need for my application that need to go into the build. So there's some more information in here about, what happens when the build occurs, and you get an email, and you can download it directly if you wait. There's also an option to publish to the cloud. So this is one of the benefits of using the Web Optimizer, is that if you have a global platform with your, excuse me, with your business, you can take advantage of having your own custom build hosted on the CDN, and then for wherever folks are in the United States or around the globe, they can then get the closest access point to download your custom build. There's some special syntax that you need to use in order to load in the custom build with the script syntax, and that's what this is right here. You can always download it and host the build locally on your own machine. You don't have to use the CDN, but you can publish that to the cloud. If you do publish to the cloud and use that CDN, it's going to have a unique signature of that URL that's going to be a combination of your username and then the build name that you gave it, and then it's going to be dojo/dojo.js. So we'll come back to this potential performance gains. So as I mentioned here, you have to upload a zip file. You just browse and upload that, enter the URL, it'll scan to figure that out, the module list, and then the manual selection there. And I have a GitHub repo out here, which over the years we've been doing this session. Let's see, which one is that in? Uploads. If you want to see what's actually in those, this is that list. And so you could copy and use that however you wanted. And then there's the compact preset. So whenever you select those, that's basically what you're beginning with or starting with. And then in here, if you were looking for a specific Esri module, say like the snapping manager, you just type that in there and it'll start finding the module for you, and you check that, and then that gets added to the modules that will be put into your build. So I had mentioned that it's kind of painful with creating that list. I have an example here, which is an editing application, and this is the reason why this is kind of important is that editing is one of those things that sort of falls outside of, not every application needs to edit. There's a lot of modules that go in there with the widget, the template picker, the snapping manager, a bunch of other modules that not everyone's going to need. So whenever we load this, if I move this out of the way, in my dev tools here I have open, I have the JavaScript and then selected, and you'll see it load, and down here you see like the number of requests, like 207 of the 316 requests were for JavaScript files. Now I have another, well, let's save this first. So in the dev tools, you can just right click and you can say save as har, which is the waterfall, the network waterfall. And that saves that out to this basically like JSON file. I have a script that I created that, let's see here. So whenever I run that, and I can put this in debug mode here in a minute, basically it parses that har file, and then it creates this network results text file, and it also creates a modules text file. And what that did is it, first of all, it has the ability to, and this is just, I wrote all this, so it's nothing special. The known modules, you can put an array of known modules that you want to have included in there. And then it parses the har file and it creates this network results. Basically, it loops through and it says, oh, if this starts with Digit, Dojo, or Esri, it's going to be one of the ones that we're interested in. And then other application URLs and then other URLs that are in the waterfall. So basically, it captures all that network traffic that the browser's spitting out, and it's parsing all that. And then it creates this modules text file for you that you could then upload and put into that would then, basically help you create your custom build. So you'd likely go through this like multiple times. So you'd do this, you'd create a build, you'd download the build, you'd apply the build to your application, you'd run it again, you'd look at the waterfall and see if there was missed modules again, and you'll get to a point where you don't have any more modules in there that you're missing. So I'll just rename this one to old. And then rename this one, because the complete one is the one that has, I've already done this, so you don't have to wait and watch through all this. So you can see that went down to 8. And you can see here that dojo.js is a 1.5 meg file. Rene's going to talk a little bit later about lazy loading modules, so if you're going, well, how come the vector tile implementation layer's in there? We'll cover that a little bit later. But these other ones are JSON callbacks, but you can see that the app loaded very quickly and there wasn't very many network requests for modules. So that was just kind of a big picture there on how you can create those module lists. And that's all out here on under this repo. So when you talk about optimizing, today we're really just focusing on the builds, but there is other things as well. Application load time is one of those things. Service load, the performance of that. So if your service is under a big load, like a lot of people requesting it, that's going to cause the overall experience of your application to seem less than optimal. Some folks have security with their applications where they send traffic through proxies that can potentially create a bottleneck. You can have issues where you're bringing too much geometry and or attributes to the client, and that's just overloading the client application with content that it may not need for the current use case or user of your application. And then also with that geometry, putting tons of graphics into the feature layer or something like that can also cause performance issues. So just wanted to touch upon that a little bit because all of it sort of holistically that goes together is the performance of your, or the optimization of your application, but the build is one of the important parts of it. So I think with that, I will turn it over to Rene and let him make your ears bleed.
Let's see if we get this working. I'm on number 3. All right, awesome. So real quick before we start diving into this, on the stuff that Lloyd was talking about when it comes to like the graphics on the page and drawing a bunch of stuff, using SVG, there's like a limit to like what SVG can actually draw on the page for you, and we push those limits constantly. I think between what we do in the JavaScript API and probably what like D3 does, we're probably 2 of the biggest SVG users in terms of APIs. And if you have a lot of data, we're talking like hundreds, thousands of features that you kind of need to show on a map, our suggestion is always use map image layer. In 4x, use map image layer. 3x, use dynamic map service layer. It's just a single image. It can draw all the data that you want. You can apply definition expressions to that data to filter what's shown. You can even change the rendering of what the data is going to look like. And then when you start getting down to maybe zoomed in closer to some areas, then you can turn on a feature layer. And that's an application level optimization that you can do where you just kind of turn things on and off based on the scale level of your map when you're working with it. I just wanted to touch on that because it has come up a couple of times at the JavaScript island. It's a nice little optimization you can do with your own application development. So let's dive in on the Bower stuff here. Anyone here use Bower? All right, cool, awesome. You guys, anyone here like use NPM to do things? All right, other than just instructions from there. Okay, cool. So if you don't know, Bower is basically just it's a package manager for building client-side applications. So it's similar to NPM. NPM can be a package manager for building client-side apps. Its main use has been for doing some back-end stuff and doing tooling development. All right, so Bower is more about bringing in packages you're actually going to use for development purposes, to building the application. You can find the repo on GitHub, go through the repo, you install it by just Bower install ArcGIS API. You can do the hashtag 4.3.0 will get you the 4x version, and then 3.20.0 will get you 320. And we have everything, I think, from 4.0 up, and I believe it's 3.16 up on Bower. So you can always go back to a previous version if you want to. Some good things that we can get away with the Bower repo too is that if for some reason we have to put a patch after the fact current release, maybe Chrome breaks something, we can go back to a current release, kind of fix that in Bower. I changed the tag names, you guys never know what happened. I can't do that for older releases, or it really breaks the Git history and stuff. Or else I gotta do some weird Git stuff, and I'm not into doing weird Git stuff. So why Bower? So it makes it easier for us, for you as a developer, to manage the dependencies when you build the JavaScript application. And it makes it easier for us to do it for you as well, because like this current release, we upgraded our Dojo version to 1.12.1, used to be 1.11.2. You don't need to know about that. We are just gonna go ahead and set the Bower dependencies of our repo to the proper dependencies that we need. Plus, we also point them to forks of some of the Dojo repos, like Dojo, DojoX, and stuff, because we have patches in there. Most of our patches are nothing big. People ask, why don't we just push our patches to Dojo sometimes? That's because for 3x, for example, there's something in there. We added like something for the graphics, like a has value in Dojo for like Esri dash something. They're not gonna take that, they don't want that, but we need it for legacy stuff. And most of the other stuff is just for locales, adding new locale support for certain things. So it's not like a huge issue there. And the tooling fits with the build system. And I'll cover why NPM just won't work. And it's not magic or anything like that in a moment. But basically, you can set the bower to install things where you want them to be installed and named correctly. So what do you get? You get the JavaScript API unbuilt. We don't build it. It's completely minified. And when we say unbuilt, that's because when you run your code through the Dojo build system, it will add these like cached objects for certain things and certain files, like they're called layer files and stuff. That's when you have a built file. We do not run it through that. We basically just minify all of the source code and then throw it up on GitHub for you to use as you wish. So it's basically the same thing that we would do internally when we need to build the JavaScript API or our apps. We do provide some pure source code for you though. We use Sass for doing our CSS development for the JavaScript API and with our design group and everything. It works out really well with us. We even use PostCSS along with Sass to do stuff. We do a lot of development stuff when it comes to design pieces with our group, but we realize that some people might be interested in using Sass, so we provide those source Sass files for you. We also provide the source code for all of our widget views, and I think we've talked about this before. Let me over here. So I think we've talked about the fact that with the widgets, we have this whole view model thing, which I won't go into detail, but to give you an idea of how we use view models, we actually provide the source for our own widgets so you can see how we do it. I'm making myself reverberate here, get back. So like we have the base map gallery TypeScript file in here, and this is exactly what's inside of our own repo when we do our development. So you can see exactly how we built the widget. You can see how we use the view model. I'm a big fan of the way that our widget guys do this CSS object in here when they do their styling for the widgets, and they kind of modify this on the fly as needed. It comes in really handy, as a matter of fact. I really like how they do that. But you can see everything in here. You can even see all the comments we put in here. I think at one point that was released in here, someone had a comment of like, I don't know why I'm doing this, and it went out there. Stuff's there. You can even see how, a lot of times people are interested in how we build our documentation. You can look at our JS doc that we have inside these files, and this is how we do our documentation. So if you're interested in that kind of thing, not many people are, but some people geek out on that kind of stuff. It's pretty cool. But yeah, so all that's in there for you to go ahead and use how you need to use it. It's custom builds. So I'm going to get into how to do custom builds of the JavaScript API using the Dojo build system. It can be a little overwhelming at first. There's a lot of moving pieces. Dojo has some decent documentation on it, but I think the documentation could probably be a little bit better. They might be working on some of that stuff down the road. And it's just the fact that there's a lot of different things you can do. There's the basics that you should do when you do a Dojo build, but then there's a lot of really advanced stuff that you probably never need to know about until you need to know about one of those things, and those advanced features are kind of hidden away in the documentation there. You can use required.js for custom builds, and I'll talk a little bit about those limitations and some of the key points about the build system and some of the limitations that you should know. First, I want to go over some of the frustrations that you might feel. Why can't I just npm install the API? So first off, because I know people think that because they're using Webpack, and Webpack lets you just npm install modules, and then Webpack can build those modules. If you npm install the JavaScript API, it's not going to help you. I guarantee it. The fact is that some of the issues that the Webpack has with our building the JavaScript API has nothing to do with npm. It's just the fact that we use loader plugins, and Webpack does not understand what to do with loader plugins with our modules or Dojo modules. And we use loader plugins for kind of stuff that Lloyd was talking about, the lazy loading. That comes in handy a lot of times because specifically for IE10N support, if we need to load in a locale file for showing text in a widget, we check what locale you're in during module loading time, and we load the proper locales needed at that time. And Webpack just doesn't understand how to read those loader plugins. Why is the download so big? So we've been doing a lot of work on this with 3x and particularly 4x, where when you download the init.js, the regular one, not the compact build, we throw in things for authentication. So we have our identity manager in there, and that handles a ton of different authentications. I can only imagine how many authentication schemes people in this room probably work with, and we handle them all, which is a pretty big feat. The web map support, so we take a pretty good guess that you're probably using a tile layer, you're probably using a feature layer. We don't know if you're using a KML layer or CSV layer, so we will lazy load those files as needed to draw that kind of stuff, depending on what you're going to do. But in 3x, we kind of had a lot of files in that initial build, but we've done some work to kind of break some of that out a bit more. And we're looking more like, okay, if you load the Esri map, we know probably what you're going to do. But then if you load a certain layer, maybe like the CSV layer or a feature layer, we know that you may need these other modules as well, pop-up stuff and everything else. So we'll load those with it. So we're trying to build more layer files in the API to get the downloads down a bit more. But there's pros and cons. I mean, you can over-optimize for your applications. One of the things we saw came up not too long ago was the fact that someone did their single build file. And it might be my fault because I've recommended this before, you could do it. You can deploy a single built file to your production environment. So you have one JavaScript file and everything's great until a file tries to get lazy loaded. Now you don't have access to those files anymore because you only deployed one. You don't have the Esri file, the Dojo file, whatever needs to get lazy loaded, and your application breaks. So try not to over-optimize. It's a safe bet to let the Dojo build system do what the Dojo build system wants to do. Yes, you deploy a lot of files, but you really probably only use one most of the time, but there is going to be those cases where in your runtime of your application that something might try to get lazy loaded and you're going to need it. I think how many people saw some of the HTTP2 stuff in the plenary? We're really interested in that. All of the CDNs for the JavaScript API is HTTP2 enabled. If you're using an HTTP2 compatible browser, you'll start seeing benefits on that. And it's for the JavaScript files as well as the tiles now too. So the tiles and everything comes down at once. So we're really interested in those optimizations. And we're even thinking that, we played around with the fact of what happens if we don't deploy a built JavaScript API. What if we just deploy all of the JavaScript API minified files and let the browser do it? Supposedly HTTP2 will get better performance the more files are trying to download. So we're playing around with some different schemes and stuff that we might be able to take advantage of down the line for that. Okay, so let's get into some stuff I'm going to show you here. So first off, before you, to understand Dojo, to understand how the module system, everything works, there's a couple of posts that are up on GeoNet that I'd written a while ago. One's called Embrace Your AMD Modules, and it kind of goes through on what an AMD module is. So this is a good example here. Basically, when you call require or define, and you give it a package name / a file name, it's expecting that to be a folder / file name. So if I require app sample, that should be in a folder called app, and it should be a file called sample.js. That file will have a module with a define method. All right, and I've got stuff in here about how you can define the packages. So defining packages is key. Dojo lives in a packaged world, so like Dojo is a package, Dojo X is a package, Digit's a package. Your application, app, most of the time it's going to be called app. You're not going to call your package source. Your package would be called app. That's a package. So you define that as a package, and Dojo is going to understand whenever you look for something in app, it's going to try and pull stuff out of your package. I've seen people build out their own custom widget libraries and deploy them as packages within the organization, and they call them like they call it widget, but like digit, the digit library with the W. I've seen that. I don't know if those guys are here. They're not. But yeah, they did that. That was kind of cool. I have another one that talks more about AMD packages here and why AMD packages matter. This post here is really kind of cool because it shows how you should try to structure your application. And if you follow this way of structuring your application and you go and try to use the web optimizer, then things are going to work out pretty nicely. The web optimizer will be happy, you'll be happy, and you'll get a really nice clean build out of that. So we looked at the Bower repo here. All right, we've got some, so we got the 3x and we have 4x up in here, and you can see all the different modules. We have the README down here that tells you what all dependencies currently are. Like I said, we just upgraded to most Dojo stuff to 1.12.1. Some of them are off the Esri forks. Some of them are directly from like dstore. We just use it directly as is. Xstyle is only used in 3x right now. We don't use it anymore in 4 and other things like that. So there's a great page on creating builds that Dojo has. This is their page on how you do builds, right? This is probably the first starting point you're going to get to. Like I said, this will get you so far, and there's probably, this could use some more samples, I think, on how to do stuff, but this has stuff that I'm going to show you here. So let's go with where I'm at. Okay, so here is a repo that we have on, this is files from a repo we have in GitHub called JS API resources. In this repo, we have samples for 3x and 4x. I'm going to show you 4. I don't do 3x stuff anymore. So let's go with 4. We have a Bower folder under 4x here. In that folder, we have both Dojo and require.js. So let's just look at my application real quick. My app is just like I have a main.js file that's going to create a scene view. That's all it does. Nothing too crazy with this, right? You'll notice my app folder, I've got this package.js file. That package.js is what's called a profile for a package. And that profile just has to have something letting the Dojo build system know, hey, this package contains AMD files, and that's what this resource tags does. The code here just, basically this means that every JavaScript file in this folder is an AMD file, part of my package. And this is where you can exclude like test files and stuff. You can tell the Dojo build system, ignore my test for my package, ignore any kind of like demo files or something like that. They're no big deal. Just checking my time here. I tend to go over time, I'm sorry. You can also give a package.json. Now the package.json will let the Dojo build system know how to find your package's profile. So you can see here Dojo build property, I point to package.js. That means you could have called package.js oatmeal.js. It doesn't really care. It's a good convention to probably call it either the name of your package or just call it package.js. And you'll actually see that in a lot of these other Dojo's ones. If you come down here, their package.json has a Dojo build that points to their package.js. You can look through some of theirs. Theirs are more complicated in terms of what you want to exclude and stuff. Don't get scared off of them. If you want to ignore them, just ignore them. It's no big deal. Just, you can look through their stuff. All right, so we have our Bower stuff in here, and this is one of the reasons that we like Bower. The fact is, I can tell Bower, I want you to install to a specific directory. I can't tell NPM I want to install to a specific directory. NPM is going to install node modules no matter what. It doesn't care what I say. Bower, I can tell it where I want to put my files, which is key when you want to do Dojo builds and keep everything nice and uniform. So I want all my Bower installs to go in the source directory. I have a Bower JSON file here. Now, if you notice, I have my dependencies. My dependencies says, you know what, I'm going to have an Esri folder. That Esri folder is going to be pulling the files from this ArcGIS JS API repo, but I want you to keep that folder name as Esri. You can't really do this with NPM. You can't tell NPM, hey, I want you to install, NPM install the JavaScript API, but call it an Esri folder. Don't call it JavaScript API or something. You can't get away with that. If you did it, you could do it, but what's going to happen, it's going to make your profile more difficult. So let's look at what the build profile looks like. All right, so let's not get scared off too much of this stuff. There's a lot in the build profiles. I'm going to skip over some things or gloss over a few things. Don't worry about it. They're not too critical if I gloss over them. This optimize options, this is a more recent addition to the Dojo build system, probably like the last couple of releases. That's because they updated the closure compiler. Now we can tell closure to build output to ES5. Previously, we weren't able to pass options to the closure compiler because it's a Java tool, And the way the Dojo build system worked, we couldn't pass options to that Java tool unless we ran our build in Java, and we just did not want to do that to do stuff. Base path, meaning that I'm looking at the source file. That's my base for this profile. And my optimize options, I can use Clojure or I can use Uglify. If you use Clojure, you may get better smaller files by a few bytes or so, but you got to use Java. It's a Java tool. You can use Uglify, and actually Uglify will probably work just great. We did run into issues running Uglify on our minified source code on Windows. I never figured out what happened, but it would just kind of get stuck in a loop. And I think it has something to do with Uglify trying to minify minified code. So if you run into an issue, go back to Clojure and you should be good to go. Now here's where we define our packages. So we're already in the source directory. Now I just need to tell the build system, hey, I have a folder called app, that's a package. I have a folder called digit dojo and so on. Now I have another package called moment. The moment looks a little odd. That's because moment, although moment is delivered as a UMD package, meaning that it can be used as CommonJS or AMD, moment does not have its own package.js file. It doesn't have any way for the Dojo build system to know that, hey, it's AMD. So you can tell the Dojo build system it's AMD by telling it the name, location, target. Basically that moment/moment is my target file. This trees here, looks pretty complicated. It really is just a way to tell the build system, ignore any test directories, text files, source directories, templates, and all kinds of stuff that comes with the moment install. And then again, the resource tag saying everything left over, if it's JavaScript, is an AMD package, go ahead and build it as is. Things get interesting down here, we do these layers. So we have a layer file, and it's called dojo/dojo. This means that when I build my application, everything's gonna get built into the dojo/dojo.js file. It's gonna turn into a large file in 4x for 3D. You can probably squeeze a bare application into about 1.2 megabytes, maybe 1 megabyte if you're lucky, depending on what you're doing. In 3x, you can get that down to like a few hundred K, since there's no 3D in 3x. So what you want to tell the build system is that in this build file, I want you to look at the app main file, and then Dojo build system is going to recursively go through app main. It's going to figure out what all the dependencies are, and it's going to build them into that Dojo.js file for you. There are some files in the API that are dynamically loaded, like we've been talking about, dynamically loading some things, and that will not show up when it does a dependency trace on app main. And that has to do with some of the GFX stuff that we still use for SVG. So we have to bring those in. We have some stuff here that we had to do some stuff for 4x because with the vector tiles, the way they work is that we use workers to load all the vector tile data. And actually we have an entire worker framework in the API that we don't really talk about yet. We will be probably talking about more in the future. It's just not something we think is quite useful at the moment for app developers, but we're using it for all of our worker stuff. And because of that, when we do our application builds and when we have the API code, these particular files here, which have DOM dependencies, are not automatically loaded. So you have to tell the Dojo build system, hey, load these files for me. I know that I said I don't need them, but this Dojo file does need them. And then there's some other files. These are a lot of the files that we dynamically load in the API that have to do with the 3D, WebGL, and creating layers and stuff. Because so much stuff happens with WebGL, and don't ask me WebGL questions, but the way the WebGL stuff gets loaded, these guys do some pretty complicated things, so they only bring in a lot of these files when needed, because a lot of these files can have a hefty size to them, like a few K, but it can turn into a couple K in your build system. So we add those into the build file for this one. And then we have this thing here for including locales. I just added this to show you how you can include locales into your build files. I'm including just English, but you can include Spanish, French, Hindi now. We have in 4 and 3. So then what you want to do is we're going to create another build file. We're going to create a file for vector tile layer view 2D, right? And that one's going to include itself. I don't know why we do that. I forget again why that happens like that. But we include that file by itself, meaning we're going to trace its dependencies, build them all into a single file in that one, but we want to exclude the map view. We don't want the map view to be included in this because the map view has a whole chain of dependencies that we're already loading in an app main. So we don't want to double up on our how we're loading our files here. We do the same thing for these worker files. The worker files are the same thing. So we have built layer files specifically for the worker stuff. That way, if we didn't do this, what would happen is that if you're using, when you load the API and you have your single Dojo file and you think, oh, hey, I'm happy. But then the workers start working, they start loading in all these other files again. They're going to get like 50 files getting loaded. And you're going, well, what's happening here? Why are all these files getting loaded up? And that's because the workers work inside of their own context, separate from the files that got loaded in the browser. So they don't know those files exist or are available. They're just going to load the files as needed. But if we build everything into a built file, now they're not going to try and load 50 files because they already have them available in their own context. So that's why we do that, if that made sense, I hope. Don't worry about static has features and stuff. These are just options that the Dojo compiler can use. And then we have a default config. And again, I won't put too much into detail into this. These are some more advanced things. One thing we do recommend though, and I will tell you this one, is that if you are going to build your application, you might even want to do this if you're not, use this config deferred instrumentation one. This one here is a recommended one because what this does is that Dojo Deferred under the hood does some like, it has checks to do some sort of like error checking and whatnot when promises get returned. If you turn this off, it'll make the promises faster, just slightly. I mean, it's not a huge improvement, but when you're working in 3D land and things have to happen within a single frame, yeah, it does help. And again, you just tell the build system what the packages are going to be, and you're good to go. And it looks a little weird here. I'm going up one folder here from like my app because the base URL is going to be that Dojo file. So I have to go up one URL into the same context that Dojo's in and look for app and so on, and go up, back, the way that goes. Okay, I know that was a lot. That's probably like the biggest part of doing these Dojo build systems is that build profile. Once you got the build profile done, you're pretty good to go. And we have these for both 3x and 4x in the JS API resources repo, which is, if I go over here, on GitHub here. You'll find other stuff in here for TypeScript, frameworks, and whatnot in there. I gotta go 2 screens, I should improve that. So let me show you a couple options that we put in here. And I did this because when we first started releasing the Bower stuff, people were like, oh, you only included a grunt file to show me how to do my applications. And we do. We have the grunt file in here that shows how you can run the build. There's a grunt Dojo tool that just has a few options. You tell it where your build profile is. You tell it where your Dojo file is. There's some default options for build that you pass in and use that. And the grunt file works just fine. It'll deploy your application to a dist directory, and we actually look at that here. If we look at the Dojo/Dojo.js, it's just this massive file now with all my code built into it. So the grunt file works great. It does everything it does, but people are like, oh, you only gave me a grunt file. I don't use grunt. I'm using something ridiculous. They wanted gulp. So okay, great. So we have a gulp file. Shows you how to use gulp. Okay, so that made everybody happy. You have to pass some commands into gulp so things will run. And then just because just being a smartass, I put a make file in here to show you how you can do your Dojo build system using the make file. If you want to get old school, did I do package scripts? And I didn't do a script. I should do an NPM script too, just to make everybody happy. So yeah, so you have a lot of different options when you do your builds, because you can essentially just run the build from the command line using Node. You run Node, call the Dojo.js file. I know it sounds weird to call the Dojo.js file, but the Dojo.js file has some stuff tooling that's built inside it that knows how to send stuff to the build system. And that build system, actually, if you ever want to look at some of that stuff, I don't know why you would, but if you ever wanted to, is in this util module. It's the Dojo util module. They've actually got samples in here, build examples that you can look at. They have an example of Dojo.js, example code profiles. You can do timestamps on your builds and stuff. They have a sample on how you use require.js to load Dojo stuff. So, I mean, there's things in there if people are ever interested in that, and no one ever looks in here. And you probably should every now and then. It's kind of cool. They show how this trees stuff works and everything. So there's stuff out there that just maybe not get talked about too much, but it's there. All right, so how am I on time here? Because I covered a lot of stuff. So I got a few minutes. So I'm going to go over some other stuff. So yes, I'm not going to go over too much of the require.js because the require.js works. The only thing I'll say about require.js is that we can get you so far, but require.js is going to crap out on some files. And it has to do, again, it's a weird thing. This bugged us for a long time. So require.js build system, RJS optimizer runs in Node. It does Node to do the build system. Well, Node doesn't have access to a window or document. So if there's any code that references that, which happens to be some of the loaders, then like, when you try and do a has check for locale, we're trying to go to the browser to find out what locale you're in. So you don't get that in Node. So require.js fails on those loaders. We were like, well, that's weird because we're running Dojo with the Node tools to do the build. How does Dojo do it? We couldn't figure it out. Well, it turns out, after talking to the Dojo guys, they actually have hooks in their build system that they put mock loader tools whenever they call loader, and they fake it. They basically just fake the loading of that loader and make it work. And it killed me. I spent like 2 weeks trying to figure out what was going on there, and that was the problem the whole time. So we actually have a grunt file in here for require.js that so here's a sample build file with all the includes. Looks pretty similar to the stuff that we did for Dojo, right? But you have to tell it to exclude some stuff, like DOM ready has, which is a loader plugin, I18N. It has this way to ignore modules by saying, give it the module name, and then give it this empty with a snake eyes. Someone told me snake eyes after that, right? It's a Python thing, snake eyes, right? So empty snake eyes, in the text after that, and that tells the require.js optimizer, ignore that module, don't try to load it, don't do anything, let me do my build. With require.js, you can get a build with the ArcGIS optimizer probably down to about under 20 files for sure, and probably down to a dozen depending on what you're doing. We had helped some people out with this, and it worked pretty well for them when they were doing it. So if you have to use require.js, you can use the JavaScript API and everything to do your builds. Okay, let's get into some other stuff real quick. I got a few minutes here, and hopefully we can take some questions after. Other options, rollup. What's rollup.js? Rollup.js works with ES6 imports modules. So if you're writing your code in ES6, it has a way that it goes to all the imports. It really shines when all of the dependencies you use are providing ES6. So if you're using like Lodash as an ES6 modules and stuff, because it will only bundle the code that it is being used in your application. So it traces all the imports that are being used, ignores the ones that aren't being used, and then you get a nice little bundled file. They call this tree shaking. It's really only an ES6 kind of thing though. So your code has to be all in ES6. If you don't know ES6, it's how you do these import statements here. This is how you do it in ES6, how you do it in TypeScript. It works really well with that. And there's a good blog post on it. On Medium, tree shaking and dead code elimination, the differences, and I won't go into the differences there. All right, so I have before I get into my repos here, I've got a sample. We've got a couple guys actually, buddy Tom Wason, I mentioned him a lot because he helps out in a lot of this stuff here. He's got a roll-up example here where he built an application, and I like the idea of doing this because he uses roll-up, builds his application, right? Let me get app.js here. So he's got his regular application, he's got some Dojo stuff happening in here. Builds the application, uses rollup to build his app, but ignores the Dojo Esri files. So they don't get included in part of the rollup script. All the rest of the application does. You get a very nice bundle after the fact. You get this nice minified file here. And then what he does, he just lets the CDN load as it normally loads. So the Esri and Dojo files don't get caught up in the rollup build steps, and then we just use the CDN. This is useful if you want to combine this method here with the web optimizer and do an optimized build of your application after the fact. So now you can have an optimized CDN URL, and you have a bundled application JS file that you can use, and you get the best of both worlds. That works. It's a pretty nice tool set if it's something that you're looking to do. But again, all your code has to be ES6, and it's really only beneficial if your dependencies, if you're using something other than JavaScript API, maybe like another framework or their libraries, that those are also ES6 files are provided for you that you can point them to. Another one is Webpack. So there's some guys here, I think they might be showing some Webpack stuff yesterday or maybe today. Randy Jones and George, I can never say his last name. Beard, long hair guy, totally awesome guys. They were doing some enterprise build stuff, and they helped come up with a lot of these Webpack things that we're trying to figure out, because Webpack, like I mentioned earlier, just won't work with our JavaScript API and load modules. There's a bit that they came up with though. I think they did this. I can't remember if they did it or if Tom did it. I get really confused at these points, where basically you tell the Webpack build system to ignore the Dojo, DojoX, Digit, and Esri modules. Just have to ignore all these modules that are JavaScript API specific. Do the Webpack build again, you get your nice bundle the same way you did, like you did with Rollup, but you can just use the CDN anyway to get all your files in there. Because you're going to tell Webpack to create an AMD package of everything, and then the JavaScript API will be able to load all that stuff nice and friendly, and you live in a very nice, happy world. But it's not a single file build, and you still rely on the CDN. But again, you can use Web Optimizer, create your optimized CDN. If you want to add an extra build step, and I wouldn't recommend it, but if you want to do a local build of the JavaScript API and then shove it into this after you do this own build, so you have like 2 builds kind of run, you could do that as well. That would work. We were doing that, something similar with the operation dashboards, where we did our own build using Ember, and then we did a separate build of the JavaScript API, and then we copied that build file into our folder for our deployment after the fact and then pointed to it. We just use a CDN now. We don't even bother doing it anymore. It was too much of a hassle. So, okay, so I think that's all I got to show on that stuff. I went over that kind of quickly, but trust me, it's pretty good. And I'll let Lloyd do this other bit here. What number are you? 4. All right.
So just some other considerations. We didn't really talk about it, but you can, depending on the state of your data, how often it changes, you can do data generalization using the desktop tools to clean up or simplify the geometries of, say, like polygon boundaries. The less geometry you send to the client, say for the feature layer, the better performance you're going to get. If you're not doing editing, and depending on what scale you're at, visualizing the data, you don't need all that data at the client anyway. Gzip compression, that's something that you can enable at your web server tier. That helps compress the files on the server end, send them to the client. The browsers can then decompress that, and then just with the stuff that Rene talked about with file minification, but you can do that with assets as well. If it's, SVG, or if you're, not too many people use them anymore, but like image sprites, and there's node packages to run your image assets through image optimization techniques as well. So maybe you have your raw high resolution assets or whatever, and you can run them through these minification operations that will optimize the files for the web. So this is, just some of the resources. I'm sure Rene and I'll be updating the other repo, the Web Optimizer JS repo, after the Dev Summit, and then, Please fill out the session feedback. Let us know if we're hitting the points that you want to see.
I want to show one other thing that I forgot to show before. I have a repo out there, and it's just called Gen4. It was just a demo thing. This is based off I have a generator for JavaScript applications. I haven't updated it in a while. I need to update it for 4.3. But basically, it's a Yeoman generator that will spit out a JavaScript application for you that has all of the Dojo build stuff in it and more. it will actually go through and, there's a lot of stuff here in this grunt file. It will actually go through and copy Dojo.js to an app.js file. It will go through all the CSS resources, create a single CSS file, and then scan that. It will then take all of the resources, move them to a single folder, and then update all the URL paths in your CSS file. So now you have one folder for assets, one CSS file, one JavaScript file, one index.html file, and it will also go ahead and do cache busting on the app.js and CSS file for you. It's a highly optimized way. It can be a little dangerous because then you may fall into the trap, like I mentioned earlier, where you may try to lazy load a file after the fact and it may not be available. So you got to kind of be smart in how you do it and make it require some user testing after the fact to copy files over that you may need at a later point. But I just wanted to mention that because I mention that all the time and people seem to like it, so cool.
So thank you. Questions?
Give us the presentation URL again. Do you have a presentation URL?
Oh, for the slides themselves?
For the slides, that we can, do you have a URL for these slides?
Oh, they're going to offer the slides thing after the fact. We have to combine our slides because we worked on the two parts separately, so we have to combine our PowerPoint later on, and then we can put them out at some point down the road.
Right, the proceedings URL,
Yeah.
they'll be out there. What's that? Longer than next week, maybe within a month. I mean, okay, so we released last week. The conference was this week. I mean, everybody's probably going to take a deep breath next week, and then we'll have like a week to get our slide decks in, probably like 2 or 3 weeks. It's usually a pretty fast turnaround time.
Yeah, because we'll probably get the email like Monday, like, hey, you guys upload your slides here somewhere. Yes.
Is there an option in the gives or your main.js file or something?
Yes, you can remove. You'll strip all comments and you remove all logs. There's like different levels for removing logging. To remove logs, remove warnings, remove errors. So you want to be careful with that though, because sometimes if you're using console.log to catch errors, if you remove all the console.logs, you remove your error output stuff. So you want to make sure that if you're doing that, they're actually either throwing an error when you catch it or using console.error or warn, I believe, to do something like that. But yeah, you can remove all the logs and everything else. Right there? Test in the build system? Well, I mean, we use intern for all of our testing on the JavaScript API, but we don't build our test.
I know, but do you have a separate, because I suppose you have some continuous integration, and you put it somewhere in the path, this test. Do you put it before the building or today? How it goes?
No, how's the CI stuff work? So we deploy out to a continuous integration server. We don't build it when that happens. When we do our builds, we just run them through sanity test once they've been built to make sure everything's working. After build, and it's pretty much a series of like applications that get run on via some testing software someone has to open all the apps and make sure that everything works with the builds as they should. No, Dojo doesn't have that out of the box. What we do is we actually run the TypeScript compilation as we're developing. And actually right now when we check into our repo for JS API, we don't check in our JavaScript. Everyone has to run the TypeScript build tools themselves and generate the JavaScript and do all that. But when we do run the build, the first thing we have like in our node script is run the TypeScript builds compiler, and then we run the build system after that fact. But it's not directly part of the Dojo build steps.
So
No, well, the TypeScript it does have in the Bower repo are the source files for the widgets, but you don't need to build them because we also provide the built JavaScript files in there as well. You don't need to worry about that, yeah. Sorry. Yes?
You didn't talk about the performance improvements, like what is the relative improvements?
With the Dojo build system? Oh, the web optimizer stuff.
Oh, yeah. Sorry about that. In the using the web optimizer guide topic, it just talks about some of the various requests and size differences between what can happen depending on what modules are in your application. You know, it's basically you're downloading a larger file that has all the modules in it versus doing multiple requests to download the individual files. But like as Rene was saying, with HTTP 2 coming, at some point in time, there's going to sort of be like an optimization flux where, you know, should I really be doing this much bundling, or, you know, because whenever it's a multi-threaded process to fetch these files, really the network is what's going to kind of come into play there. Thanks for reminding me. I forgot to show that.
I think you could. What you would do at that case is you would point the Esri loader into your built JavaScript file instead of a CDN. And instead of you know, the CDN having to download maybe half a dozen files for whatever you're using an Esri loader, you just download the one, everything packaged in there. But it's a build step you'd have to run in conjunction with however you're building the rest of the application. So maybe you run your Webpack build, and after the Webpack build runs, then you run the Dojo build, which can take like a solid 5 minutes or more, depending on what you're doing. So if you wanted to do that, you could. It may be something, if you're gonna do, only test it out, make sure it works once, and then only do it when you deploy. Don't bother with development steps. When you deploy, just have some scripts to run it, and that replace, maybe have that as part of the config or an environment variable, it's depending what the URL, what CDN or built file, and that way when you deploy, you're good to go and you only have to do that once. Because the Dojo build system, I didn't really talk about that yet, the Dojo build system does take a while. I mean, it could take a solid 5, I think the longest I've seen happen with an app that I was working on was like 8 minutes on a slower machine. But yeah, it does take a while. It does a lot of analyzing and stuff. Anything else? Awesome, thanks guys, appreciate it.